Artificial neural network-based fusion method. Artificial neural networks, ANNs, have proven to be a more powerful and self-adaptive method of pattern recognition as compared to traditional linear and simple nonlinear analyses. The ANN-based method employs a nonlinear response function that iterates many times in a special network structure in order to learn the complex functional relationship between input and output training data. The general schematic diagram of the ANN-based image fusion method can be seen in General schematic diagram of the ANN-based image fusion method. The input layer has several neurons, which represent the feature factors extracted and normalized from image A and image B. The function of each neuron is a sigmoid function given by N. The hidden layer has several neurons and the output layer has one neuron, or more neuron. The ith neuron of the input layer connects with the JTH neuron of the hidden layer by weight phi, and weight between the JTH neuron of the hidden layer and the TTH neuron of output layer is VJT, in this case t equals 1. The weighting function is used to simulate and recognize the response relationship between features of fused image and corresponding feature from original images, image A and image B. The ANN model is given as follows. In equation 6, y equals pixel value of fused image exported from the neural network model, q equals number of nodes hidden, q8 here, vj equals weight between JTH hidden node and output node. In this case, there is only one output node, c equals threshold of the output node, hj equals exported values from the JTH hidden node. Where vi equals weight between ith input node and the JTH hidden node, I equals values of the ith input factor, n equals number of nodes of input, n5 here, hj equals threshold of the JTH hidden node. As the first step of ANN-based data fusion, two registered images are decomposed into several blocks with size of m and n. Then, features of the corresponding blocks in the two original images are extracted, and the normalized feature vector incident to neural networks can be constructed. The features used here to evaluate the fusion effect are normally spatial frequency, visibility, and edge. The next step is to select some vector samples to train neural networks. An ANN is a universal function approximator that directly adapts to any nonlinear function defined by a representative set of training data. Once trained, the ANN model can remember a functional relationship and be used for further calculations. For these reasons, the ANN concept has been adopted to develop strongly nonlinear models for multiple sensors data fusion. Thomas et al. Discussed the optimal fusion method of TV and infrared images using artificial neural networks. After that, many neural network models have been proposed for image fusion such as BP, SOFM, and ArtMap neural networks. BP algorithm has been mostly used. However, the convergence of BP networks is slow and the global minima of the error space may not be always achieved. As an unsupervised network, SOFM network clusters input sample through competitive learning. But the number of output neurons should be set before constructing neural networks model. RBF neural network can approximate objective function at any precise level if enough hidden units are provided. The advantages of RBF network training include no iteration, few training parameters, high training speed, simply process and memory functions. Hong explored the way that using RBF neural networks combined with nearest neighbor clustering method to cluster, and membership weighting is used to fuse. Experiments show this method can obtain the better effect of cluster fusion with proper width parameter. Gale et al. Used adaptive resonance theory, ART, neural networks to form a new framework for self-organizing information fusion. The ArtMap neural network can act as a self-organizing expert system to derive hierarchical knowledge structures from inconsistent training data. ArtMap information fusion resolves apparent contradictions in input pixel labels by assigning output classes to levels in a knowledge hierarchy. Wing et al. Presented a feature-level image fusion method based on segmentation region and neural networks. The results indicated that this combined fusion scheme was more efficient than that of traditional methods. The ANN-based fusion method exploits the pattern recognition capabilities of artificial neural networks, and meanwhile, the learning capability of neural networks makes it feasible to customize the image fusion process. Many of applications indicated that the ANN-based fusion methods had more advantages than traditional statistical methods, especially when input multiple sensor data were incomplete or with much noises. It is often served as an efficient decision-level fusion tools for its self-learning characters, especially in land use/land cover classification. In addition, the multiple inputs minus multiple outputs framework make it to be a possible approach to fuse high-dimension data, such as long-term time series data or hyperspectral data.